Delphi unit testing. This is the first time I'm at ITDevCon. Recap of yesterday, a conference organized by passionate Delphi developers for an international audience. And I like it very much. So I hope to be invited next year as well, because this is an awesome conference. I'm a one-man company called C#.net. So people can hire me to do consultancy and work in both the Delphi and .NET areas. I've been in the Delphi world, well, actually, I've been in Anders Hejlsberg's world since Turbo Pascal 1. Anders Hejlsberg is the original author of Turbo Pascal 1 and now works at Microsoft looking after the .NET framework and the C# language. Which means that I've been doing Pascal programming since like 1982 or something like that. So I'm not far. And I love both developing and helping out people with information, teaching people, and making them smile at the end of the day, so that because they can solve problems for their own software development. So if you have a question, interrupt me. The idea is you learn more than I do. I learn during every presentation I give because of the interaction with people like you. So please interrupt me. It's about the dynamics of a session. So I love to teach. I used to be a partner at a training company doing almost exclusive teaching. That was too much teaching and too little development. I found out that you need to do a lot of development in order to be able to talk about what you do. And now it's much more balanced. I do development time about 80% of the time and conference and teaching about 20% of the time. So, introduction to unit testing. How do you correctly pronounce the last name of Marco? Okay, I won't try that, but thanks. So he's in T component, which is the self room, downstairs the big room. Right after this one. I thought, wow, it's good that I have this on the sheet, because my memory sometimes loses itself. So two questions for you guys. Who of you are doing unit testing? Okay, no hands. Then an even more important question. Why are you not doing unit testing? And be honest about it. What's holding you back doing unit testing? So let's ask the three people here. Why aren't you doing unit testing? Okay, you have old software and you find it difficult to write unit tests for it. Okay, that's a very good reason. That's what I hear a lot. Okay, okay. Other people having different reasons why they do not do unit testing. For instance, you. Okay, old software. Let me just start with a very simple example on how unit testing in Delphi can look like. What I have here is a group of demo projects that that most of my unit tests of our public repository are in. And this one is a very simple one. It's the project called free and nil pointer unit test project. What it basically does is test the free and nil function. So it consists of a main program that includes the test framework and a GUI test runner. So what it does, it compiles a project that has a graphical user interfacing around all the tests in the project. And instead of having a normal Delphi application where it says application in each create form blah blah and then run, it says GUI test runner, run all the tests that have been registered. And inside it are tests. And the tests are in units. For instance, the free nil pointer unit is what I want to test, and the free nil pointer test case unit is the test case that I'm going to run. Let's take a very quick look at what I'm going to test. This looks like a traditional Delphi function. The whole idea about unit testing is that you can test procedures or classes that have methods. Unit testing is about testing small portions of code, be it old code in a procedural way or more modern code in an object-oriented way. So you can test simple stuff like this. And what you do is for each functionality, you write a test case. So let's go to the test case. And the test case is in the test case unit. A unit that has test cases always includes the test framework in the users list. And you derive a test case as a class deriving from tTestCase. tTestCase is in the test framework. And I'm using dunit because that's the standard unit testing framework for Delphi, and it ships with Delphi, I think, since Delphi 7 or something, maybe even 6. So it's been there for forever. Okay. I need to ask this question. Who is using Delphi 7 or below? Great. That means all of you, okay, one person. This should be in Delphi 7, but you can also download it from SourceForge. I'll show you the link in a few moments. And if I don't, please remind me that I do. Just interrupt me. So this has been in Delphi forever. And in fact, there's a wizard that allows you to create a new unit test framework, a unit test application. Under other, there's this unit test thing where you can create a test project, and within a test project you can create a test case. So everything you need is in Delphi. If you have an old version of Delphi, then you can download it. I made a promise. I'll try to fulfill all the promises I made. It's on dunit.sourceforge.net. And if you Google for dunit download, it's the first hit. So it's very easy, easy to get. And if you download it, you get a zip file, and you're done. So when you have a test case, it always starts with two procedures, setup and tear down. Let's run this first, and then I'll show you what the setup and tear down are for. So I'll run this. So when you run the GUI, it'll come up with a tree that contains all the tests that have been registered. And what you see here is just like Delphi, it has a run button. And it's also bound to the F9 function key. So when you press F9, it'll run all the registered tests. And since the tests here are small, it's very fast. And now they're all green, which means that all tests are OK. If a test is not OK, it's either red or purple, depending on why it doesn't work. What you see is this is the test case class. And inside the test case class are tests. And for each run of a test, a new instance of the test case class is being instantiated. So that means that when this function is being run, you get a fresh new instance of T3 and nil pointer test case. So each time a method is run, setup will run, and after the method is run, tear down will run. And there you can do initialization or cleanup of things you need for your test. For now, they're empty. If you want to test a simple procedure, you don't need to do anything for initialization or cleanup. And then we go to the actual tests. And the actual test methods all need to be published. Published normally is associated with the object inspector. When you have a published property, the object inspector knows that you can edit the property. In the form designer, when you have a button with an on-click event, the button one-click method is also in a published section. You don't see it because it's the default section, but because it is published, you can ask this class how many methods are there and what parameters do these methods have. And DUnit is looking for methods in a published section that have no parameter. Then it knows, okay, this is a method that we can run a test for. So these three methods don't have a parameter, and they will show up in the test list for this test case. The part about the CLR is not used anymore. This was created when there was a Delphi.NET compiler, and the Delphi.NET compiler is now Prism. So this is not needed, but it's still in the wizard. So the wizard generates it. You can delete this portion of the code if it confuses you. Don't worry about that. So this is basically for a simple unit test what you need. And inside the unit test, you test your functionality. So what I do here, I want to test the free and nil method and see what happened and if it's doing okay. And there's a couple of free and nil, the default free and nil from the runtime library, a free mem and nil, and another one here for free mem and nil where there's a size parameter involved. What I do here is I create a new object. I check if the object is not nil, because if I create one, I expect an object to exist. And this is inherited, the check true, and a lot of other methods are inherited from the t-test case in the test framework. So there's check true, and there's a check for certain values, etc., etc. And we will dive into more advanced methods shortly after this demo. And then I free and nil the instance, and after that I expect the instance to be nil. So unit tests are about running a piece of code and then checking if the piece of code does certain things. And in this case, if the result is either not nil or nil. And if instance is not nil, the test fails and becomes red. So what I can do is just fool my test and expect not nil after free and nil. And if I run it, you see that this test fails. And the reason it fails is memory should be nil after a call to free and nil expected true, but it was false. So the test fails. Okay. The really cool thing about unit testing is you can start small. You don't have to write tests for all your code. That's one of the reasons I didn't hear people talk about. But I've done similar presentations like this on other conferences and training, and it's something people are afraid of. Oh, I start unit testing, now I have to write tests for all my code. That's a lot of work, and you don't need to write it right now for all your code. In fact, you probably will never write unit tests for all your code. You want to write unit tests for a code that's either used very often or code that you think, well, I'm not sure if this actually works in all circumstances. This is code that I think will break soon. Let's test this one because it's the highest risk. So don't think, well, I need to do everything right now. That's not true. So you can start very small with things like this. The whole idea about unit testing is about measuring the quality of your code. And the more unit tests you have, the more you can say over the overall quality of your code base. So it makes sense creating more and more and more unit tests code over time. But there's no need to have 100% code coverage. That's the term they use for measuring how much of the code is in fact tested by all the unit tests. I've never seen a project that had 100% code coverage, because that means that you've done so much test work that, well, almost no company can afford that, because it's costing a lot of time. So you need to find a balance on how much you want to test. The cool thing is, when you start writing unit tests, you have a test suite that gets bigger and bigger and bigger and bigger over time. Which means that you can run them each time your project changes and make sure that everything you did in the past still works. And the higher your code coverage is, the better you can guarantee that previous functionality still works if you add new functionality. Or, what happens a lot in projects, well, we did this 2 years ago, and now added this a year ago, and added that half a year ago, and it becomes a bit hard to maintain, and you need to restructure your code to make the design better. That's called refactoring. And if you have unit tests for the old code, you can guarantee that the old code still works after you optimize the design. So those are two advantages of having a good code coverage. And an excellent spot for writing a unit test is a bug report. A client comes in, says, if I do this, that, and that, it'll break. If you can isolate that to a single procedure or a class that has a couple of methods, you can write a unit test for that. Solve it. See if the client can still reproduce the bug. And if the bug is solved, then that unit test is a great way to make sure that if you ever change the code again, that bug will not appear again. And that's the real power of unit tests. It makes sure that things you did in the past still work when you change the underlying code. Okay, am I doing unit tests? Yes, but I should do it more. I have the same problem as you guys. There's 24 hours in a day. There's work for like 50 hours in a day. So I need to find a balance on what new code I write, what tests I write, what integration scripts I write, what sessions with clients I have. So for me, I have the same problem as you. I need to choose what to do and when. And these are a couple of the examples where I successfully used unit tests in my projects and had the time to adapt them and make them public so I could use them in presentations like these. And you can do it from one extreme to another. I see a lot of projects where they do not do testing. They, well, no, there's almost no project that's actually here. Most projects are, okay, it compiles, ship it. Back in 1991, I was working for a client. That was in the period I was studying. And doing work was so much fun that in fact, I stopped studying chemistry and started my own business. The most important thing I learned from my study is to find stuff on the internet. So I know how to Google search for the unit download and stuff like that. That's the most important thing I learned during my study. And the project was finished, and the client needed someone, they needed to hire someone for a permanent position in order to maintain the code. So I interviewed a couple of people, and I recommended one, and I forgot to ask him how his development routine was. And he was the kind of person, oh, it compiles, let's ship it. I learned a very important lesson there. You need to be keen on quality and in your daily routine, what you do and when you decide to ship software. That was a very important, I was 21, so I was very young, but I still regret that mistake very much, because it was a stupid mistake if I thought about that a little bit longer. Most projects are the common sense kind of projects. I mean, you guys don't do unit testing because you have old code, but you probably have end users that do some testing for you, right? Okay. Unit testing is only a small part of an overall testing strategy. And in fact, there's no company I know that doesn't do any testing at all. Most of them are in the common sense tests, area, or in the ad hoc testing area. They write code and have some end users do some testing on it and see if new functionality breaks and existing functionality still works. But that's from a user interface perspective, and unit testing is from a code perspective. Then there's sanity testing, and if you go all the way, you do test-driven development, and then you do not write any code until you write your tests first. I'm not here. I'm here, well, in between here and there. And if it's sensitive code, I write my tests first. It's very sensitive code, because I need to find a balance for clients as well. This is test-driven development to the extreme. You write a test, it'll fail because there's no underlying code. Then you make a change to the code, run the test again, and if it still fails, then you make changes to the code until it succeeds. And if it succeeds, then you start writing a new test. And then this guarantees that you can have 100% code coverage. But it also costs a lot of time. This you see, for instance, in the medical industry, where you need to guarantee that a machine will not kill somebody. Okay. Most of our software, when it fails, nobody will die, right? Okay. And it's all about risk versus quality. And the unit tests test your code. Code is very important because code telling what the program does. The ultimate form of documentation is your code. Because the Word documents and the design specifications, they are always behind on what your code actually does. Then there's regression testing. That tests for things you broke. Things that used to work in the past and that do not work anymore. And unit tests help there because in the regression, it's an early warning if you broke things in your code. Regression testing is a bit more broad because unit testing cannot test a user interface. Unit tests test code. And regression testing can be run from a user interface. And then there's integration testing, which you also should do, and it tests your software in the context of a live system with communicating with a bank transfer, or a web service, or a database connection, etc. And then there's user acceptance testing, and that's what most companies do, test the full product. And there's a big testing paradox. Because when you try very hard to make sure to find all bugs, you still have more subtle bugs left in your code. Because if you solve this big one, there's probably some small bug underneath. And that's the fact of life. You cannot solve all the bugs. It's software. Software has bugs. Because if it didn't have bugs, we would have an unlimited amount of time to write all the tests and do it perfectly. Why test? Well, if you test, you will have less bugs. And if the number of bugs decrease over time while you still work on code, you're doing a good job. And that's what we try to do, right? Okay. So, a couple of reasons. People think it's complex, don't know where to start, need some knowledge. Another problem that Marco will address is what about dependencies of your code on other systems or other code? And you can use a Spring framework for that. What about the outside world? Because I'm testing a small piece of code, and it doesn't only depend on other code, it depends on a database connection, or it depends on some web service, or on some cloud system, or you name it. That's when you need to do some mocking. You need to simulate the outside world and make sure the outside world is in a consistent way before your tests start. And Marco will tell a bit more about that later on as well. A good way is starting with a bug report and write the unit test. You now know how to measure your fix, and if the unit test succeeds and the end user is fine, then it's okay. If your unit test succeeds and the end user says, no, it still fails, then the unit test only reveals part of the bug, and you need to write another unit test to make sure that the end user will be happy. So having unit tests is a bug repellent. It's like the bug spray, right? It prevents the same bug from reappearing, and sometimes bugs in the same area for appearing in your code. So this is a very powerful aspect of having testing, not only unit testing, any kind of testing in place. It prevents bugs from happening in an early stage. So when you introduce a bug and you immediately find it, it will cost some amount of time. And if you find about it here, it will cost more time, and if you find it here, it costs even more time. In reality, the graph is not a line, it's exponential, so it goes up. So the sooner you find out about a bug, the cheaper it is to fix it. And that's what you need to think about when writing development. Unit testing is part of that. Being aware of how this works is very important in that. In fact, a couple of projects, I've been working with 2 people on the same machine. And for certain kinds of code, it's cheaper having 2 people on the same machine because you immediately check each other and prevent bugs from even appearing. I did some very complex communication code where this was very successful. So you need to be creative to make sure that bugs won't happen or that you find them very, very soon. And the cool thing is, I've run them from the IDE, but you can run them also from the command line, which means that you can run them from a batch file or from some automated system that runs a test every night or every time something changes in the version control. Who is not using version control? Okay, great. Because most version control systems allow you to run unit tests in the background in some way or the other. Marco will probably tell a little bit about that later on. And I need to show you how that works. So I made a console version of the same test project. And the whole trick is that you can define a console and have a function isConsole, and if it's console, then it will run the text runner, and otherwise it will run the GUI runner. I'll put a breakpoint here, and then you see that you have text output, and then it says, well, 3 tests succeeded. And there's tools that allow you to filter the output and write a nice email on what succeeded and what didn't succeed. Okay. One of the reasons I write a lot of tests is similar to why I write a blog. It takes time to do it, just like it takes time to do unit testing. But I do so many different things, and I have such a tiny memory that I don't remember all the details of what I did in the past. So I write it down, a small summary, which I can search using Google. And it saved me hundreds of hours already in the last couple of years. I did a small calculation how much time I have invested over the last 3 years, which is 5,500 hours. It's about 10% of a working day. Actually, it's less. And it saved me a lot of time because I can find back stuff I did in the past and find the details. And as a bonus, there's about 700 people reading it every day and learning from it and having an advantage as well. And the same with unit testing. You write unit tests for yourself, but also for your colleagues, and to make sure that things you did in the past still work today and save time today, tomorrow, next month, and a year from now, and the whole future. This is something that Marco will tell more about. This is, let's do a little bit more of demos of stuff that you can test and what I've done in practice. Who's using client data sets? Okay. Who is using data snap and stuff like that? Okay, that's more people. One of the things you can do with a client data set is save the data as an XML file. In one project, I decided to use that XML file to communicate with external Java systems, because then I was sure Delphi could read that file. Well, the Java people had trouble generating that kind of XML. So what I needed was a way to describe how that XML would look like. And there is one way to describe XML is using XSD. It's a description of how an XML file should look like. And there was no XSD file, no existing XSD file for the XML that DataSnap would use. So I wrote it myself. So I started writing XSD, and more XSD, and I needed a test case. So what we have here is XML that comes from a client data set, and the 2 XSD files that I used to describe the XML. And what I do here is see if my XML validator can successfully validate this XML file using 2 XSD files. And this is a way where you can use unit tests, not only for testing Delphi code, but testing an external dependency on XSD files. And it's, from a setup, it's still a test case. And now I have a setup method that creates an XML validator object and a teardown that frees the XML validator object. And my test doesn't only test some Delphi code. No, it makes sure the file exists. And if it doesn't, it says self-check true, so the test will fail. And and then runs the XML validator. And if it doesn't validate, it says check true on false. I probably could have done fail or something like that. Yeah, I could have done fail, but in this part of the session, it's easier to talk about check methods. And then a message, why it fails. So this is an example where you do not only test Delphi code, but also some XSD. Okay. Who is not using XML a lot? Okay, a few people are not using XML. So for that, I have another unit test that tests an EOS error. That's an exception for an operating system error that you often can get when you have wrong characters in your XML. And that's this one. What you see here, let's first do the wrong XML file. What you see here is an accented character. American and English people don't have accented characters, but in Europe we have. So you see this a lot in text files. The problem is, this will not load. Do you have any idea why this will not load? Sorry? The encoding. The encoding is wrong. And the reason it's wrong is that the default encoding for XML is some form of Unicode. It's usually UTF-8. This is a standard Windows text file. So it's using Windows encoding and not Unicode encoding. What happens here, if you load it, is that you get an error. This was from the early days I was using XML, and I knew nothing about encoding. So here I learned about encoding. The good text file says the encoding is Western European encoding 1252, Windows. You can, I did a hex dump of it to see that it's in fact E0. And that's the Windows way of saying this is an A with an accent that way. I always forget how you call this accent. It's a backtick. So I wrote a little bit of test code here in this unit. And the first one loads an XML document, and in the load XML document, if it doesn't load, it raises an exception. And what it does, it gets the parse error. This is from the XML interface. So the XML document can tell you what went wrong. And I wrote an exception class around it because I love my error messages not to be as strings. I want to have my error messages as Delphi exceptions, because Delphi exceptions you can raise and you can have a try except block react on them. So what it does, it parses it and then raises the exception. And my test case is actually for this particular class. If it correctly raises an exception in the wrong case, and if it does, and to make sure it does not raise an exception in a correct case. So that's why I have two files. One file I'm sure that will fail, and another file that I'm sure that will succeed. And when you run this, it raises an exception. And this one should fail, and this one should succeed. But wait, don't we all want to have the tests to be green? we do. And the cool thing is DUnit knows about exceptions. And that's why I wrote this little example. An exception handling project. And this will raise exceptions in a controlled way. And this was my project to learn about how DUnit does exception handling and how to cope with it. So I have an exception raiser, and it can raise an exception. Oh, no, it has a couple of methods. One that will always raise an exception, one that will never raise an exception, one that sometimes raises an exception, and one that raises an exception that I do not want. So there's two kinds of exceptions that you can handle. It's the kind of exception that you expect, and it's the kind of exception that you do not expect. The unwanted exception is the kind I want to fail, and the other exception is the kind of exception that I expect to happen in a certain position. For instance, for this XML, I know the file is bad, so I expect an exception that will tell me, hey, this file is bad. And that way the unit test will be green. Okay. So how do you test on these? Well, you write another test case. And here are the different ways that exceptions can happen and that I test for. So writing test cases and test methods is just like bookkeeping. You make a matrix of all the possibilities and make sure you will check for all the possibilities. It's dull work some of the times, which means that some developers are very good at dull work, and some developers are not good at dull work. So in your organization, you must make sure that people that are good at bookkeeping make these kinds of unit tests. And people that are bad at unit keeping do not write these kinds of unit tests because they will probably get it wrong. And that's one of the other things that I want to teach you during this session. When developing software, you need to be aware what kind of persons you have in your organization and what they are good at and what they're not good at, and give them work that they are good at and happy with. Because a happy programmer is much more productive than an unhappy programmer. Right? Okay. The whole trick for DUnit and exceptions is that you can tell it that it should start expecting an exception. And that's in abstract test. So there is a method called start expecting exception, and what you do is you give it the class of what it should expect. And at the end of your code, you tell it that it should stop expecting that exception. If you write test cases, you need to use common sense like you write normal code. So if you write normal code and you have to do the same thing three times or more, you need to sit down and think, why am I writing the same code this many times? There must be a simpler way. And the same is for unit tests. Unit tests are Delphi code. So if you think this is the same thing over and over again, make it more simple and do it the same way you write regular Delphi code. So it took me about a day to write all the tests and make sure that I had the right structure. And then I had someone, I could do the English part myself, and I could do the Dutch part myself, but I had a German friend filling all the German varieties. And there's, in fact, one subtle thing that my algorithm doesn't do right. It's this one. hey, you say, this here is the same as that. It's not. It's not. There's a little irregularity in the German way of writing down numbers. In this particular case, you need one extra S after the ein. Ein is the German word for one. And because German has female, male, and thing words, you need this extra S. So there you see that doing language things is difficult. And that's why you need language unit tests for doing language things. Okay, you can ping me on Twitter. This is my blog. You can write me email. If you Google my name on the internet, you will find me. My last name is not very common. My middle name is not very common, so you'll find me. So thanks very much for your attention, and enjoy the rest of the conference today.